Imagine waking up one day and the sun is gone. No light, no warmth, just an endless night. The sun is not just the center of our solar system, it's the very reason life exists on Earth. It provides the energy that drives photosynthesis, fuels our weather systems, and keeps our planet at just the right temperature to sustain life. But how well do we really know this fiery giant? Beneath its dazzling glow lies a universe of secrets. What happens in its core, the very heart of its power? Why does its surface erupt with incredible force, flinging solar material into space? And why is its outer atmosphere, the corona, hotter than the surface itself? In this video, we'll take you on an epic journey to uncover the mysteries of the sun, our closest star, and one of the most intriguing phenomena in the universe. Buckle up for an adventure that will take you deep into the heart of the sun and beyond. Let's start at the very center, the sun's core. This is where the magic of nuclear fusion takes place, a process that powers the entire solar system. Deep within, at temperatures of 15 million degrees Celsius, 27 million degrees Fahrenheit, hydrogen atoms are squeezed together under immense pressure, colliding and fusing into helium. This process releases an astronomical amount of energy, including light and heat. To put it in perspective, every second, the sun produces as much energy as 1 trillion 1 megaton nuclear bombs exploding simultaneously. Without this process, life on Earth would not exist. But how do we even know what's happening inside the sun when we've never been there? Scientists rely on indirect evidence, such as solar neutrinos, tiny particles produced during nuclear fusion that travel straight from the core to Earth. These neutrinos are incredibly elusive, passing through almost all matter without being absorbed. Detecting them requires massive underground observatories filled with specialized sensors. Despite these efforts, questions remain. For example, why do some observed neutrinos behave differently than predicted? And how exactly does energy take thousands or even millions of years to move from the core to the surface? The sun's interior is like a labyrinth we're still trying to map out. Moving outward, we arrive at the sun's visible surface, or photosphere, where things get even more dynamic. This is the region where sunspots appear. These dark patches are not holes, but cooler areas caused by intense magnetic activity. Sunspots can be as large as Earth and last for days or even weeks. They form because the sun's magnetic field is incredibly complex, constantly twisting and tangling as the sun rotates. When these magnetic fields snap, they release enormous amounts of energy in the form of solar flares. These flares are sudden, intense bursts of radiation that can travel at the speed of light, reaching Earth in about 8 minutes. But that's not all. Solar flares can trigger even larger events known as coronal mass ejections, CMEs. CMEs are massive eruptions of solar material that can send billions of tons of plasma hurtling into space at speeds of up to 3,000 kilometers per second. When CMEs collide with Earth's magnetic field, they create geomagnetic storms. These storms can disrupt satellite communications, power grids, and even navigation systems. For example, a massive solar storm in 1859, known as the Carrington Event, caused telegraph systems to fail and created auroras visible as far south as the Caribbean. Today, such an event could have catastrophic consequences for our technology-dependent society. Scientists are working to understand and predict these events, but the sun's magnetic behavior remains one of its greatest mysteries. Now, let's explore the sun's outer atmosphere, the corona. If you've ever seen a total solar eclipse, you've witnessed the corona as a glowing halo around the sun. This ethereal layer extends millions of kilometers into space and is filled with superheated plasma. But here's the paradox. The corona is millions of degrees hotter than the sun's surface, which is only about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. How can this be? Imagine standing next to a campfire and finding that the air farther away is hotter than the flames. This phenomenon, known as the coronal heating problem, has puzzled scientists for decades. There are several theories about what causes this extreme heat. One idea is that magnetic waves generated by the sun's surface transport energy to the corona. Another theory involves nanoflares, tiny but frequent explosions that collectively heat the plasma. To uncover the truth, NASA launched the Parker Solar Probe, a spacecraft designed to touch the sun by flying closer to it than any previous mission. The probe is equipped with instruments to measure the sun's magnetic fields, particle flows, and plasma waves. Early data from the mission has already provided new insights, but the full story of the corona's heat remains elusive. The corona also plays a crucial role in the solar wind, a stream of charged particles that flows outward from the sun and shapes the entire solar system. These particles create phenomena like the auroras and can even erode planetary atmospheres over time. Understanding the corona is not just about solving a scientific puzzle, it's about understanding the forces that govern our cosmic neighborhood. The sun's story is far from over. Right now it's in the middle of its life, burning hydrogen in a stable phase known as the main sequence. But in about 5 billion years, the sun will run out of hydrogen and start burning helium. This will cause it to expand into a red giant, a phase during which it will grow so large that it might engulf Mercury, Venus, and possibly Earth. During this phase, the sun's outer layers will be shed into space, creating a spectacular planetary nebula. Eventually, the sun's core will collapse into a white dwarf, a dense, Earth-sized remnant that will slowly cool over billions of years. By this time, Earth as we know it will no longer exist. However, humanity might have found a way to survive, either by colonizing other planets or developing technology to harness energy from other stars. The sun's future serves as a reminder of how temporary and fragile life can be in the vast cosmos. From the blazing core to the mysterious corona, the sun is a cosmic enigma. It powers life on Earth, yet its secrets continue to challenge our understanding of the universe. As we study its mysteries, we not only learn about our star, but also about the forces that shape the cosmos. The sun's future may be written in the stars, but our future depends on how well we understand and adapt to the changes it brings. So, what do you think? Could unraveling the sun's mysteries help us secure humanity's future in space? What other cosmic puzzles do you want us to explore? Let us know in the comments, and don't forget to like and subscribe for more cosmic adventures. Together, let's keep exploring.